This is 5.5 inverse trig functions. First thing, we did cover inverse functions back in chapter 2, and a lot of those things, those concepts that we covered back then are going to apply here with trig functions. So one of them is the cancellation property. So if I have, and I'm going to use sine, just like I did in my previous video, I'm going to use sine as the primary example. So if I had sine, the inverse function of sine, and again, this is the way we would write the inverse function. So sine negative, it looks like to the negative 1 power, and then parentheses sine of x, so the answer would be x. And likewise, the sine of the inverse sine of x is x. Now, something I do want to, and this is similar for other trig functions, but each of these trig functions has a restricted domain for that to be true. And you're like, well, what do you mean by restricted domain? So normally the domain on a sine function is negative infinity to infinity, so it covers all real numbers. But inverse functions cannot. So you remember back in chapter 2, we covered out inverse functions. Inverse functions, for something to be inverse function, it has to be 1-to-1. So as you start graphing the sine function, notice that it's going to start going like this, and similar like this. And to be 1-to-1, if you draw a horizontal line, it can't cross more than once. So that's why we're going to literally restrict it from negative pi over 2 to pi over 2, because then it won't start repeating after that. So we're literally just going to focus on the sine function. We're going to restrict it from here to here. So from literally negative pi over 2 to pi over 2. We're going to restrict it, and those are inverse trig functions. So again, cosine has a different restricted domain. You got to look about where it starts to repeat itself. And so the same thing with the tangent, cosecant, cotangent. With all of the trig functions, you got to look at the restricted domain. So, and just as a side comment, this is the inverse sine. That's how you pronounce it, or arc sine. And again, it's sometimes just denoted as arc sine without the e. So it's just different ways to say it. And certain calculators actually have different ways. Most of them have this, but some of them have arc sine, or some websites have the word arc sine is there, but they mean the same thing. All right, so let's start evaluating the inverse function of sine. And again, I'm using sine as the primary example. So here I'm having the inverse function of sine of 1/2. Now remember, like when we were doing inverse functions, you basically swap the x and y's, and then you solve for x, you solve for the y or the x, and then that's the inverse function. And then when you take the function of the inverse function, it's going to cancel each other out. So that's that cancellation property that we're talking about. So here, when I ask you to find the inverse sine of 1/2, we're trying to find sine of what will give me 1/2. And if you remember, a point is cosine sine. So I'm looking, and again, I'm looking from negative pi over 2 to pi over 2. So I'm looking at this part of the circle. And so the only part that is 1/2 is for sine is this guy right here. So this is pi over 6. So in other words, sine of pi over 6 is going to give us 1/2. So because this is true, so I know the inverse sine is pi over 6. Okay, so that's really what I'm trying to find. What of these measurements on the terminal points will actually help me find the inverse sine function. So here, let's try another one. So the inverse function of sine of negative 1/2. Well, likewise, it's right here. Okay, so notice I have negative pi over 6. Now here again, it says 11 pi over 6, but remember, I'm trying to find, the restricted domain is from negative pi to pi, so I'm literally just focusing on just this part of the circle, and I'm trying to find literally the distance, if you want to look at it that way, the distance on the arc angle, the angle here, the measurement of the unit circle. So it's pi over 6, and again, I'm going negative, I'm going down, so it's negative pi over 6. All right, so likewise here, and keep in mind that you're restricted, I keep saying this, but you're restricted from here to here. And also remember, every point is cosine sine, and notice the largest possible value is 1. So this is less than 1, that's less than 1, that's less than 1, and that's obviously less than 1. So there's no way that I can have a 1.5. There's no way I can do this. So this would be like undefined, or it doesn't exist. So let's now go to our calculator, and let's just evaluate this. So first of all, make sure you're in radian mode, and just literally type these into your calculator, and this would be 0.9614 if you do 4 decimal places, and this would be 0.3398. Again, pause the video, check it on your calculator, make sure you know how to calculate those. All right, so now let's evaluate these functions. Notice I have the sine, the inverse sine of sine pi over 3. Now the big thing is, notice I keep saying this over and over and over, but on the unit circle, it's defined, sine has a restricted domain from negative pi over 2 to pi over 2. And so notice this number is within that range. So I know if, and the cancellation property, so I know the inverse sine and the sine are going to cancel each other out. So the answer is pi over 3. All right, so let's look at this next one. So this next one says sine, a lot of us might be tempted to say, oh, this and this are going to cancel each other out, and you'll just write 2 pi over 3. But something that you need to pay attention to, notice first of all, this right here is not within, it's not defined within the range that, the domain that it's referring to. But focus on this part right here. So sine of 2 pi over 3. So 2 pi over 3 is right here. And this is negative 1/2 square root of 3 over 2. And so sine would be square root of 3 over 2. So just focus on just this. So the sine of that is, sine of 2 pi over 3 is square root of 3 over 2. And so now what I'm going to do is find the inverse sine of square root of 3 over 2. So again, notice where square root of 3 over 2, if you look at the unit circle, so on the unit circle within the defined domain that we have, we know we have square root of 3 over 2 is right here at pi over 3. So again, the cancellation property applies if it's within the restricted domain that we're referring to. Otherwise, you've got to actually evaluate it. All right, so that's, I've been focusing on sine primarily. Now let's look at some other functions real quick. So I just have a quick comment. Similarly with the cosine, except the domain is from 0 to pi. Now you're saying, well, why is it from 0 to pi? Well, remember the cosine function again, it goes, literally starts repeating itself from 0 to pi, and then it's going to keep going up, but to be restricted, you can't, it has to be a one-to-one function, so you can't start going back up because then it will no longer be that way. So you can literally only go from 0 to pi, okay? That's why it has a restricted domain. So again, notice the original cosine function has a restricted domain. The inverse function does, because cosine will start repeating itself. All right, so here I have 5 problems. I want you to evaluate them. You might have to pause the video to do this, but here I want to know cosine of the inverse cosine of square root of 3 over 2, and then evaluate each one of those other ones. All right, so here I put the unit circle just to remind you, but the unit circle is going to come in very handy. So here I'm evaluating the inverse cosine of square root of 3 over 2. So if you look at square root of 3 over 2, where is it square root of 3 over 2? And notice it's right here at pi over 6. The inverse cosine of 0, well, it's defined here at pi over 2. And the inverse cosine of negative 1/2. So that would be defined right here at 2 pi over 3. And again, notice, I want to say this again, it's going to come in handy in the next page. But notice it's defined from here to here for cosine. So from 0 to pi. All right. So let's look at, oops, I still have 2 more functions. So let me go backtrack on these 2. So on these 2 functions here, I have the inverse cosine of cosine 2 pi over 3. So again, 2 pi over 3 is within the restricted domain of the cosine. So that just means the cancellation property does apply. So that's 2 pi over 3. And for the last one here, notice this number is not within the restricted domain here. So because it's 5 pi over 3, that's that one right there. And so what we're going to have to do is literally evaluate this. So look at this whole thing on the inside. The cosine of 5 pi over 3 is 1/2. That's what it says. So now we're trying to find the inverse cosine of 1/2. Well, where is cosine of 1/2? It's right there at pi over 3. All right, and then lastly, let's look at tangent. And we're not going to worry about the other 3 inverse functions. We're going to just primarily do sine, cosine, and tangent. So notice with the tangent, it has a restricted domain between negative pi over 2 and pi over 2. So you could see the graph why it's that way. It's restricted because otherwise it starts repeating itself after that. And it has to be a 1-to-1 function to have an inverse. All right, so each one of these, we're going to look at tangent, the inverse tangent of 1, the inverse tangent of square root of 3, and the inverse tangent of 20. All right, so the inverse tangent of 1, so notice where is it going to equal 1 at? And remember the graph right here, pi over 2, this is pi over 4. Negative pi over 4. And at pi over 4, it equals 1. And that's where I'm looking for, so this would literally be pi over 4. And so the inverse function of tangent of the square root of 3. Well, notice what this is. If you go back to look at the unit circle, where is tangent? Keep in mind tangent is sine over cosine. And where will it equal square root of 3? Well, right here, if I have square root of 3 over 2 over 1/2, this will actually equal the square root of 3. So pi over 3 is that. And then the inverse tangent of 20, literally just grab a calculator and it equals 1.5208, approximately 4 decimal places. That's inverse functions with trig functions.